Hello everyone, welcome to day 3rd of November Leetcode challenge, and it's a bright sunny day in Delhi. Everyone is in festive mood, so let's quickly wrap up today's session. Today's question is sum root to leaf numbers. In this question, we are given a binary tree and we are also provided the information that all the nodes in the binary tree contain integer values within the range of 0 to 9 only. We need to tell the total sum of all root to leaf numbers. And how do you identify one root to leaf number? If the path is something like this 1 2 3, then it represents the number 123, wherein 1 is the root of the tree and 3 is its leaf node. Let's try and understand why in the first example that is specified we have 1 2 and 3 here. So one root to leaf path is 1 2, which makes the number 12. The other root to leaf path is 1 3, which makes the number 13. We need to add these two numbers together to return the total output, because there are two leaf nodes in the tree. One represents the number 12, the other represents the number 13. Without much ado, let's look at the presentation that I have created for this, and I'll be talking about the solution there itself. Some root to leaf numbers, Leetcode 123. It's a medium level question on Leetcode, but I would categorize it in easy category, provided we have been doing it from past 1 year, and the concept to solve this question is a post order traversal, which all of you are aware of. So let's take a slightly longer example to what was specified in the question. We have a tree that is given something like this. We have the root as 4. It has two children, 9 and 0, and 9 has further two children, 5 and 1. So the first number that is generated in this tree is along this path, which is 495. So at this position, we need to return 495 to the answer. The second number is 491 as per this path. So we need to return 491 from here and add it to our result. And the third leaf node that I can see in this tree is this one. The path is 40 and the number becomes 40. So there are three leaf nodes in the tree. We need to sum those up and return it as the answer, whatever it is. So how do we do this? The way to solve this question is by the post order traversal, because we want to process the root nodes first and then process the information at its children. So let's take this same example and let me just change the color of pen to blue. Let's start the iteration. We have 4 here and we are at the root. Let me just initialize the total sum variable with 0, which will store the answer for us. And it is initialized to 0. We are at the root. At root, we saw 4. So we will pass in 4 to its children nodes, children subtree. The first one is this, the second one is this. So 4 gets passed here as a value coming from the previous parent iteration, and at this particular tree you see a 9. So what do? You multiply the previous value by 10 and add 9 to it, the current node value, and further pass it down the tree. So 4 into 10 plus 9 becomes 49, and this value gets passed to its child node. So we have 49 getting passed from the parent to this particular leaf node, and we see it's a leaf node. We repeat the same process. We multiply this number by 10 and add the current value. So 49 into 10 becomes 490, plus 5 becomes 495. And since it was the leaf node, we add this number to the answer and we don't further progress towards the recursion stack. So this sum gets updated to 495. Let's walk through its right child now. We have 49 getting passed from this parent to 1. So we'll do the same thing. We will multiply it with 10 and add 1 to it. 49 into 10 is 490, plus 1 is 491. So we have generated 491 here. And what do we see? We see that it's a leaf node. We add it to the global answer variable. So we have 495 plus 491 now. We'll not further progress in its child nodes because it was a leaf node. Let's walk through the remaining part of the subtree, which is this one. So from the parent, 4 gets passed, and what is the value at the current position? The value is 0. So what do? We multiply it with 10. 4 into 10 plus 0 gives us 40. And since it's a leaf node, we abort the process and we don't further progress down the tree. We'll also add 40 to our result. So this becomes the total final answer, which is as expected as per the question. Now let's move on to the coding section. And the time complexity for this approach is order of n because you are traversing each node only once. We'll talk about it in the coding section. So let's go there. I have taken a global variable private int total sum that shows the total sum. Then I have created a helper method which is iterating the tree in a post order traversal fashion. Let's see how have I written this helper method. It accepts two parameters. One is a tree node and other one is the value getting passed from the parent. Since the root doesn't have any parent, I pass in 0 there. So if my root happens to be null, I simply return back and abort the process. Otherwise, I go and check if the current node happens to be a leaf node. Then I update my total sum answer variable with value into 10 plus the root node value, and I simply return back. Otherwise, I go and process it on its left child and the right child, and the value from the parent getting passed down the tree gets updated to value into 10, one coming from the parent into 10 plus the root dot value. Similarly here as well. Once I'm done with this, we simply return the total sum variable that has been updated by the iteration. Let's try this up. Accepted. Runtime is 100 times faster and space complexity is 84 times faster, which is equally good. This brings me to the end of today's session. I hope you enjoyed it. If you did, go and smash the like and subscribe button for me, and I'll see you tomorrow with another fresh question. But till then, goodbye.